In this next part, we're going to go ahead and talk about calibrating the probe and calibrating the oscilloscope. So let's first take a look at some parts of our probe. So here we have the probe and the probe tip, right? And right here we have a slider switch. And this slider switch will have two settings. The ×1, meaning there is no attenuation. You're looking at the signal at a 1-for-1, and a ×10. Now this is not an amplifier. This is not going to amplify the signal. What it's going to tend to do is look at a signal, or what it's going to ask you to do is when you look at a signal that you multiply it by a factor of 10, because the probe is actually attenuating the signal by a factor of 10. You use this switch here when the signal is larger than the graticule. But in order to calibrate the probe, we're going to go ahead and put that to the ×10. And again, on most good probes, you're going to see a calibration set screw on the connector. So let's go ahead and connect this. All right, and move that to where I can see it. Turn the oscilloscope on. And what we're going to want to do is go ahead and connect the, let's go ahead and zero that out first. We're going to connect the probe to the calibration output here on the oscilloscope. Now I've purposely messed this probe up so you can see what it looks like. So what we have here is a calibrated 0.5 volt peak-to-peak signal, square wave, and as what you can see there on the graticule on the screen is that we do have a square wave. And let me go ahead and position this so we can count the pulses. And put this at 0.1 volt per division. Well, let's make that more pronounced. Right there. So you can see that little slope on the top and bottom of each pulse. This is what we're going to actually have to calibrate and square off. So this is very simple. Just go ahead and put the, what I call this a tweaker, and to get to that set screw, and just move it one way or the other until you find, nope, do it this way. All right. And so you want to calibrate your probes prior to making any measurements, or else you might get some error. Okay. Now let's go ahead and look at the signal as that's on the oscilloscope. Excuse me for taking so long to do this. So when I want to calibrate the signal and see if I'm actually getting 0.5 volts out of the oscilloscope, let's go ahead and put this back to 1-to-1, meaning 1 volt in, I'm going to get 1 volt read, 1 volt on the probe. All right. I'll put that right in there. Okay. Now we can't see anything here because this is much larger than the screen will allow us to see. So right now I'm at 0.1 volt per division. So what I should get is 5 squares. If I'm putting out a signal of 0.5 volt peak to peak, I'm at 0.1 volt per division. I should get 5 squares. Now just to make this easy to read, I'm going to go ahead and adjust this a little higher like that. And as you can see, we have from the bottom peak 1, 2, 3, 4, 5. And that gives us a perfectly calibrated signal. If we didn't have that calibrated signal, there's a calibration knob right above the volts per division knob, and I'll show you what that looks like. So let's say we had something like this, and we know we're supposed to be getting a 0.5 volt peak-to-peak square wave. We're going to go ahead and do the calibration and make sure that this is set right there, and do not move that knob after you set the calibration. And this concludes the maintenance and calibration of the BK2190B series.